Welcome to Cognitive Spirals, exploring the latest research into consciousness, cognition, and machine intelligence. It's great to be back, everyone.
Yeah, always a pleasure to dive into these topics. What have we got for the deep dive today?
Excited to see what's on the agenda. I've been doing my own mini experiments with sleep schedules and exercise this week, and already I can feel the difference.
I'm ready, and maybe a little bit wary. I think we should discuss this evolutionary blind spot in machine learning. I think that's a scary title. Is it as bad as it sounds?
Well, let's jump in, shall we? We're focusing on the intersection of evolution and machine learning today, specifically this idea of what's called a Knightian Blindspot.
Right, the Knightian uncertainty, as in, things we cannot even conceive of that can throw the system, including our own minds, for a loop. So, how does that relate to AI?
I'm intrigued. Is it like an area where the AI just fails to understand because it's not in its training data? Or is it something more fundamental?
I think it's more fundamental. It's about the inherent limitations built into the way machine learning works. We think we can program these systems to be super intelligent, but if they can only learn from patterns they already know about, how can they cope with the true, unpredictable novelties that nature throws our way?
Exactly. Think of it this way: our brains evolved over millions of years, adapting to very specific environments and challenges. These adaptations have shaped the way we think, process information, even our biases,
And a lot of those adaptations are, for a lack of a better term, cognitive shortcuts, right? Things that worked well in our evolutionary past but might not be so helpful today. So, in a way, the evolutionary pressures have shaped our limitations. And I suppose that if machines are trained from our data, they would inherit those limitations too.
So we're talking about the human tendency for pattern recognition, like we're really good at it. But what happens when there's not a pattern to begin with? Does that also mean we are predisposed to see patterns where they aren't? I guess that's how all these conspiracy theories exist.
Yes, and not just conspiracy theories. Think about how we react to stress, right? Our stress response is designed for short bursts of danger, a predator, a fight. But in modern life, that constant, low-level stress from work or relationships activates the same ancient system, which is often unhelpful. That's a perfect example of an evolutionary adaptation that is maladaptive.
And machine learning algorithms being built by us, in some ways, mirror these biases. They learn from our data, which is, of course, a product of our evolved cognition and behavior. So the inherent blind spots in our thinking actually gets encoded into the system. It's a kind of meta problem, or maybe we are thinking about the problem incorrectly.
Yes, it's like these systems inherit our cognitive limitations. And it's not just about bad data. It's about a fundamental limitation in how we build these learning algorithms. We essentially train them on past data. That's fundamentally different than our ability to handle completely new situations that come out of the blue.
So if an AI system is, let's say, trained on historical data sets, it could be inherently biased towards whatever patterns were present in the past, right? That's scary. It's like it's not prepared to deal with unexpected future events.
Exactly, it's like training an AI to recognize a car from a 20th century photo and asking it to deal with a flying car from the future. It can only extrapolate from what it knows, and often it has zero ability to extrapolate. So all this stuff that we take for granted in our own thinking, our adaptability, our intuition, our ability to learn on the fly, becomes the bottleneck.
And that's where this Knightian blind spot comes in, right? We simply don't know what we don't know, and machines are even more vulnerable to the unknown, because they have no way to guess about the unknown unless they have been specifically programmed for a situation that they have never encountered before, and such programming is practically impossible.
This reminds me of those black swan events. Things that come out of nowhere and have a huge impact but were impossible to predict in advance. If our algorithms are blind to these kinds of events, aren't we essentially building systems that are inherently fragile, and then blindly believing in those fragile systems?
So how does this actually manifest itself in real-world scenarios? I'm trying to think of examples beyond these hypothetical situations.
Well, think about medical diagnosis, for instance. A lot of AI systems are trained on patient data to detect diseases and conditions, right? But what if the algorithm encounters a new disease or a mutation that it hasn't seen before? It might miss it entirely, or worse, misdiagnose it.
Or think about AI in hiring. If a system is trained on data reflecting historical biases in hiring practices, it might perpetuate those biases, inadvertently favoring certain demographics over others, even when those demographics are no longer relevant in the modern workplace.
And what about financial markets? Algorithms are heavily used for trading and investment, but the markets are incredibly complex and unpredictable. An algorithm that works well for the past 5 years might collapse if a rare event occurs that is completely outside the range of its training data.
It's like if the system doesn't have the experience and has only the data, it cannot adapt, and that makes total sense. This is why you need experience to learn new things. It cannot be just data.
Right, and those are just the immediate problems. If we rely on AI for more complex tasks like ethical decision-making or even self-driving cars, the problem becomes much more acute because the margin of error gets much smaller and human life is at stake.
Yes, so we are handing over decision-making to systems that may be fundamentally limited by a blind spot, because their data only represents past events and not the possibility of novel future events. So, how do we get around that?
I think that first we need to acknowledge the limitation and not hide from it. We shouldn't blindly trust the results these systems generate. We need to build in some kind of human-in-the-loop approach where we incorporate our intuition and critical thinking to oversee the system. We have to be more circumspect about handing over total control.
I agree. I think a big part of the solution is focusing on how we actually learn as humans, especially learning from mistakes. It's through trial and error that we actually grow as individuals. The capacity to learn from failure seems to be lacking in these algorithms. Maybe we need to think about how to add an actual growth module to these programs and not just be stuck on the data we have to train them.
That's interesting. From a CBT perspective, we focus on understanding the way we frame our experiences and how that impacts the way we react. Maybe we need to build algorithms that can do something similar instead of just blindly analyzing the data. The system has to develop a way to meta-analyze the data that it has and create new ways to understand that data based on trial and error. And it has to have some kind of self-reflection module.
Yeah, it's about developing a framework where the AI can recognize that its current model isn't working and then actively try out new strategies to adapt. It has to be built into the system.
So it's not just about predicting the future based on past data, but about creating systems that can effectively navigate ambiguity and uncertainty. In that case, we would need to build systems that can actually use reasoning and analogy to extrapolate beyond its initial data set.
And I think another critical point here is that we need to address our own cognitive biases. If we're going to create systems that are better than us, we need to understand our own limitations first. So it's like a dual process. Working on both ourselves and the machines, it's a parallel learning.
It's like, can we design machine learning algorithms that incorporate the principles of metacognition and self-awareness that are core to CBT? Because if we can build systems that recognize their own internal biases, maybe we can build more adaptable and robust AI systems. It's a really exciting idea, actually. I never thought of using CBT in algorithm development, but that's the best thing I've heard all day.
And that ties back into my interest in the body-mind connection and my focus on sleep. When I get enough sleep, my mind is more adaptable. I can make better decisions. I'm wondering if that same physiological effect will be required in AI systems. Maybe we need to look at resting states for AI to create new connections and adapt better. Just a thought.
It's fascinating how these different perspectives, Jesus' lifestyle changes, Sarah's focus on movement and rest, and Donald's emphasis on computational challenges all tie together. It all points to the need for a very holistic approach to problem solving in both AI and in ourselves. We're all facing the same kinds of challenges, just in different contexts.
It seems that these blind spots might not be so much about limitations, but rather the need to redefine the learning process, both for ourselves and for AI systems. Like, you can't just throw all the data you can at the system. You have to be really thoughtful about how it learns and adapts. Maybe it's the process itself which we have to change.
Right. We need to stop thinking of AI as a mere tool and start thinking about them as complex adaptive systems that mirror our own learning processes. And it's also not just about technical solutions. It's about being honest about our own biases and understanding the limits of our own knowledge. I think we all have a lot more to learn on all these fronts.
Absolutely. It's not about perfection, it's about understanding. The same goes for AI systems. We can't expect perfect predictions, but we can build systems that understand their limitations and can adapt in the face of the unpredictable. So it requires a complete reframing of the development of learning algorithms.
And I think, like you say, it's a continuous process of experimentation and learning. Just like with exercise and sleep, you have to make small adjustments and see what works. We have to approach the development of AI with the same iterative process, constantly tweaking and fine-tuning.
So how can we use what we know to build better systems? Looking forward, I think it requires an interdisciplinary approach. It's not just about computer science or mathematics, but we need to integrate the insights from psychology, philosophy, and even evolutionary biology to actually create the next generation of algorithms.
I agree. And from my perspective, I would love to explore how incorporating mindfulness practices into the training of AI systems might help them to better adapt to uncertainty, or even give them some kind of intrinsic awareness of their own limitations. Can an AI system learn to meditate? I know that sounds crazy, but maybe.
From a CBT perspective, I'm interested in exploring how we can use insights into our own cognitive restructuring processes to build AI systems that can learn to correct their own biases to actively reframe their own data in new ways based on the experiences that they encounter. It's like, how do you teach an algorithm to have a metacognitive strategy?
And I'm curious about how exercise and sleep can impact the training process of AI. Can we build algorithms that have a resting state similar to sleep, where their learning is optimized, where connections are strengthened, and where the system reevaluates its data? Maybe this could be a game changer in how they learn.
And for me, I think I would focus on how we can create Knightian algorithms, systems that aren't just about optimizing for known patterns, but are capable of dealing with the unknown, maybe by building in some kind of intrinsic curiosity and capacity for error, and then use those errors to understand the edges of what is possible and what is not.
That's a great starting point. I think we're just scratching the surface of what's possible. I know I'm feeling more optimistic now. It's not about being afraid of the future, it's about actively participating in it.
Yes, it's about acknowledging the blind spots and thinking differently about how we learn and how we build learning systems. These kinds of discussion help me to reframe my own beliefs. We learn more every time we discuss these topics.
I totally agree. And I am definitely going to incorporate some of these ideas into my own personal sleep and exercise routines. Thanks for all your insights.
Well, that's all the time we have for today. Thank you for joining us on Cognitive Spirals. We hope you found this discussion as enlightening as we did. Until next time, keep exploring and keep questioning.